Hello everybody, today I'm going to make the tutorial video of problem D for gamers by gamers of educational round 125. Okay, let's start it. So you have some recruit with attack AI and health AI and we have some recruit with attack AJ monster with attack AJ and health AJ. Then you know that uh, when the monster will defeat recruit at time HI upon AJ, and when the recruit will defeat monster, suppose there's just one recruit, then it will be HJ upon AI. So I know that for X recruits to defeat, it would be just like each recruit attacks the same monster, so it will be AI times X. Okay, or AI times 1 upon X, which is AI times X. So okay, so and we know that the monster should be defeated earlier, so we know that oh wrong side, yeah. Okay, yeah, so we know that monster should be defeated earlier, so this should be less than this. Okay, so now when we just do the shifting, it's like HI times AI times X, it should be greater than HJ times AJ. Okay, so now this was the first part, and it's like for each monster we know this value computed and for each recruit we can have this value computed and kind of something like that. Okay, we don't know this X, but let's see, that doesn't matter much. Let's see the second part. This was the first part. Second part is, let's watch out the constraints. C is just 10 to 6. Okay, so what can we do is, for we can just go to sieve, we can just apply sieve. So what we can do is, for each element from 1 to 10 to the power 6 different costs can be there. So for each cost what we can have is the maximum value of AI times HI. Okay, attack into health, this will be the value according to we have a equation AI times HI times X should be greater than AJ into HJ. Okay, so we just compute this value, and if I have two elements, suppose I have an element with 8 comma 3 at cost 3 and I have at cost 3 5 comma 5, then it's almost optimal to take 5 comma 5 because 8 3s are 24 and 5 5s are 25, so we always 25 will lead. So if we, even if we take two monsters, it will be 48 and it will be 50, so we will always take the second part. Right, so for each different cost I have at most one best possible element, right? And after that we can just apply the sieve, and I know that cost AI, then I loop to all cost with the which are as a factor of AI, like I take two elements, then the cost becomes 2 into, let me say, cost cost I, this it's nothing but CI. The power is, or the multiplication of health and attack is CI. Then for, if I have take two such elements, then the cost will be 2i and the power will be 2ci. So this is nothing but sieve, it works like a sieve. So you can, for each cost you can find the maximum possible attack into height for some AIHJ, as you can just find it, right? So for each 10 to 6 different possible costs, you know the best possible AI times HI. As you can see, take the same elements, it works like a sieve. Now it comes that for each element you have again attack of monster AJ and health of monster HJ. So again we do the same thing, you have the equation is greater than AJ times HJ. So we find this value AJ times HJ for each monster. So we find aj times hj, and now we want to find the first cost, which has this as greater, right? So it's nothing but an upper bound function, which is like a binary search or upper bound in C++. You can just binary search and find the first index in the cost array, or you can say a new array in which we store the minimum time. Let's see, whatever. Okay, cost or the final cost fc array, and just find fc of in fc we can just find the upper bound, or we can just binary search and find the first position of the fc which has this, which have some value which is greater than aj times hj. Okay, so and that position will be our answer. Okay, so let's go on to the code. This is just the input, and now we just keep -1. Sorry. Now for each n we just take the input, and it's like attack into defense. We store it in the initial values. Now we apply the sieve and store it in the final count values. Now we just do the prefix sum to find the final value, maximum final value till the ith element. Now for each query we just find the upper bound and print it. So I hope you like the video. Don't forget to like, subscribe and click the bell icon.